Okay, we're going to do another example of our binomial theorem right now. And this one is a little bit different because just instead of just having variables, we're going to have some numbers in there too to work with. So example 2 here. We are going to expand 3x minus 2 to the 5th power. First of all, we're raising this to the 5th power. And again, I don't know about you, but I don't really want to have to multiply all that out. Since it's the 5th power, we are going to look at row 5 of Pascal's triangle. And that's actually the one I have circled here. 1, 5, 10, 10, 5, 1. Remember, that tells us the coefficients that we're going to have when we actually expand this. One, 5, 10, 10, 5, 1. Now, this one's a lot trickier because we have these numbers to deal with too. It's not just our numbers in our numbers from Pascal's triangle we have to work with. We also have the 3 and the -2 we have to deal with. Okay, let's get started. Think of this as we go through too. Think of this as the -2. All right, we have 1 as the coefficient for our first term. Then the first part of my binomial is 3x. That starts to our full power, the 5th power. That -2 is going to be to the 0 power. Then I have 5. The 3x loses a power. The -2 gains a power. Ten is my next number from Pascal's triangle. The 3x loses a power. -2 gains. 10 again. And I'm going to write that down here. The 3x loses a power, so we're down to the 2nd power now. And the -2 gains a power. Oh, it's okay, Kate. The 5. 3x loses a power. -2 gains a power. And finally, 1 times 3x to the 0 power, -2 to the 5th. Now, as you can probably see here, we have a lot of other numbers that we're going to have to work with instead of just the numbers from Pascal's triangle. So if I look at this first part, for example, I have 1 times 3x to the 5th. We'll just look at this part for a second. When I have 3x to the 5th power, I have to take 3 to the 5th power and x to the 5th power. Okay. So I'm going to do that real quick. And 3 to the 5th power is 243. So this whole first chunk here becomes 1 times 243x to the 5th. And then that -2 to the 0 power I don't really need. Now let's look at this part. 5 times 3x to the 4th times -2. Remember our order of operations. We have to do the exponents first. 3x to the 4th power is 81 x to the 4th times -2. We'll have some more simplifying to do here too, but I'm going to take this step and then we'll simplify a little bit more next. 10 times this 3x cubed would be 27x cubed. Negative 2 squared would be positive 4. Then, that was this guy. Come down to our next one. 10 times 3x squared. That 3x squared is going to be 9x squared. Negative 2 to the third is negative 8. And then we have this 5 times 3x to the first. Negative 2 to the fourth power is positive 16. Plus 3x to the 0 power. Okay, I don't really need to write that. Negative 2 to the fifth is negative 32. All right, we're almost done with this one. We're almost done. The last thing I have to do is multiply the numbers that we have. So 1 times 243x to the fifth is just 243x to the fifth. 5 times 81 times negative 2 would be minus 810x to the fourth. 10 times 27 times 4 is 1080 x cubed. 10 times 9 times negative 8 is minus 720 x squared. 5 times 3 times 16 is 240x. And then minus 32. Just be really, really careful, remembering your order of operations, and remembering to actually take, like in this case, the 3x to the fifth power. Remember to take that 3 to the fifth, and you'll be okay.